Welcome you all in today's maths webinar on the topic number theory by Mr. Maruti Sharma. Before we begin, I would like to tell brief about IMM. IMM is a volunteer body of inspired K-12 mathematics teachers, principals, and educators. It has more than 450 members who are all connected to each other on WhatsApp groups to discuss continuously problems associated to maths, teaching, learning, and assessment. The journey of IMM was begun 4 years back, and as of now, IMM has successfully organized 3 annual mathematics conclave in Delhi, where about 150 passionate and dedicated math teachers and educators participated. Other than annual conclaves, IMM also organized various IMM meet, which were held at a smaller scale, and these meets were based on different mathematics themes and ideas which were emerged and needed special attention at that time. Currently, IMM took COVID-19 as a blessing in disguise and started using online platform to organize various theme-based math sessions. So today's session is the fourth session in such series. This time we are able to make our presence on Facebook Live also, and all credit goes to Mr. Rohit Upadhyay, a young and dynamic mathematics mentor and teacher in Delhi administration. And yes, for those who don't know me, myself Amit Bajaj, a passionate mathematics lover, and currently working as maths faculty in CRPF School Rohini. Once again, on behalf of IMM, I welcome you all. So we have among us our speaker of the day, Mr. Maruti J. Sharma. He is a polymath who is working with students, teachers, and teacher educators all across the globe, from playgroup to research level. So he had a lot of work experience and currently is working with the JKMS and SCRT Delhi and SCRT Haryana. He is the founder, member, and promoter of Robotron, coding, electronics, and robotics for future technology. Are you here, Mr. Maruti?
Yes, please, sir. Thank you.
Yeah, please, stage is all yours.
Thanks so much. Trillions of thanks to Rohit sir and Amit sir, because of whom this initiative we have taken. And I am not a technical person right now. I'm just learning the basic codes because I am very much a fan of mathematical concepts, how to apply mathematics in electronics and physics. I am working with Dr. S.C. Sharma. Professor S.C. Verma is author of Concepts of Physics from IIT Kanpur. And with Verma sir, we are working under IAPT, Indian Association of Physics Teachers. Physics is the main segment where we are applying mathematics from tip to top. I'm not going in depth because we have limitation of time today. I'm just coming after sharing my screen. I have a question to each one of you. Please confirm once you can see my screen fully. Some of you please indicate in chat box. Just write down Y or yes. Great, fine. Now screen is visible to you. Thank you so much. Thank you so much. Now today's topic is number theory. I am doing research on Vedic mathematics. Vedic mathematics is a system of 8,000 years old mathematical system. When in Bharat, Indus Valley civilization was being established, being designed. And from that time till now, 21st century का ये चल रहा है कोरोना का देख रहे हैं pandemic situation. We are locked at home. We are learning day by day a new concept in technology. हम पास आ रहे हैं टेक्नोलॉजी के साथ में लेकर. So the basic root is somewhere mathematics only. And I am sharing the fundamental of mathematics, that is number theory. Without number theory, nothing is there. Srinivas Ramanujan Iyengar or Sushri Shakuntala Devi Sharma. These two greatest mathematicians of their different segments, we can say master, magicians were there. जिसने उन्होंने काम किया मैथमेटिक्स की फील्ड में पेपर का डिग्री सपोर्ट ना होते हुए भी इन्होंने बेसिक्स से लेके टॉप तक so much concept they have rediscovered, and the base was number. I'm starting from number theory only. And may I request to Amit sir and Rohit sir, please, in case you are following the messages, any queries coming there, please inform me in between. Is it okay?
Okay, sir. Okay.
Thank you so much. I am starting here.
Yes, please.
As the group is mixed full है हम लोगों का आज काफी टीचर्स इसमें हैं पीआरटी के भी टीजीटी पीजीटी सारे ग्रुप्स हमारे पास आए हैं ऑलरेडी थैंक्स फॉर योर वैल्यूएबल टाइम आई एम स्टार्टिंग कंसेप्ट फ्रॉम प्राइमरी लेवल फर्स्ट नंबर्स हम देखते हैं विच आर सिंपली 1 2 3 4 एंड सो ऑन ये हम फॉलो कर रहे हैं एनसीईआरटी या फिर आईसीएसई या फिर आईवी डिप्लोमा का जो बेसिक पैटर्न है पढ़ाने का स्कूल्स में First of all, we are guiding students natural numbers. Then we are adding zero. We are moving on whole number. We are adding negatives, and we are moving to integers, then fractions, and so on. This is the sequence of training what we are following in different schools patterns. In Vedic mathematics, we start from prime number theory first. In many of the books, I can say. Most probably in all of the books, the definition of prime number is given as a number is a prime if it can have exactly two divisors. Agree? I repeat. A number is a prime if it can have exactly two divisors. All agree? Fine. Now, in case we are sticking to this definition, बच्चों को यही पढ़ाते रहेंगे तो बच्चे आगे की प्रॉब्लम्स करने में कहीं ना कहीं कंफ्यूज होंगे कैसे होंगे देखते हैं प्रॉब्लम्स को मैं स्टार्ट करूंगा एनसीईआरटी के क्वेश्चन से देन विल मूव ऑन टू ओलंपियाड प्रॉब्लम्स फर्दर लेट्स से फर्स्ट क्वेश्चन फ्रॉम एनसीईआरटी क्लास 4th बुक नंबर 10 कैन हैव हाउ मेनी डिवाइजर्स Number 10 can have how many divisors? And I am just clicking the answer box also. Chat box open कर लेता हूँ right side में, but I can see parallelly. Answer is coming very fast from many of you. You know very well. Answer is 4. But same question if I am converting, just see the difficulty level because we are all are trainers. I am not going in very slow process because हम सब पढ़ा रहे हैं स्कूलों में. In case the problem is, let's say we have to find number 1 crore can have how many divisors? आज से केबीसी की एंट्री स्टार्ट हो गई ध्यान रखिएगा अमिताभ बच्चन जी का नया प्रोमो आ गया था कि फ्रॉम 9th of May they are starting entry in KBC आज से क्वेश्चन स्टार्ट हो गए हैं we have to remember there are 7 zeros in 1 crore many of us can answer it very fast fantastic yes it's a prime number concept for class 4th only in Vedic mathematics we are introducing these concepts in class 4th only okay I think those who are answering correct, they are not teaching only class 4. They are teaching somewhere in class 10th, 11th, 12th also. Right. Mega is saying which we used to do in higher classes. We'll just discuss how we can work on these concepts. हमने भी बात की थोड़ी देर पहले कि 10 के 4 डिवाइजर पॉसिबल हैं कैसे आया ये how we could find it observe it carefully if I write 10 is equal to how many prime numbers can divide 10 exactly 2 which are those 2 and 5 now index the powers not powers exactly. The word power is a little bit confusing in primary classes. You should use index. 2 index 1, 5 index 1. Now, if I take a vertical system here, which is column-wise process, this 2 index 1 can be divided by 2 numbers, 1 and 2. This 5 index 1 can be divided by 2 numbers, 1 and 5. Now, we have 2 outputs in first column, 2 outputs in second column. It means total 4 divisors, which are 1 into 1 is 1, 1 into 2 is 2, 1 into 5 is 5 and 2 into 5 is 10. Just imagine, if अगर हम इस तरह पढ़ाएंगे बच्चों को क्लास 4th में, तो can't they do magic of that permutation combination of bigger numbers very fast? Class 4th बच्चा जो भी 7 या 8 या 9 years का हो रहा है, if the child is understanding concepts like this column wise process समझ रहा है वो धीरे धीरे, when the child will enter into 7th or 10th or 11th future classes, which kind of development we can see in future? Just imagine. Now those who are teaching only primary classes, they must focus on second approach to 1 crore. In 1 crore we had 7 zeros. It means 2 into 5 is coming 7 times. Index is 7. 2 index 7, 5 index 7. Now, in case index is 7, we can have 1, 2, 2 index 2, 2 index 3, 2 index 4, 2 index 5, 2 index 6, 2 index 7. Same for 5, 1, 5, 5 index 2, 5 index 3 up to 5 index 7. In both the columns, we will have 8 members each. And 8 cross 8 is 64. We can not only make particular column process, we can ask the children to please find the exact divisors. They can write it very fast. In class 4 only. I'm just asking from primary section teacher, because are they satisfied with this concept? Because others, I think they would be very much clear. But from primary level, we have to start it. Miss Mega S is convinced. Anybody else? Nanita Sinha is convinced. Anybody else? Please comment in chat box. Please write. Okay, thanks a lot. Thank you so much. Now, I'm just coming on to some problems from different papers which are being offered from different level Olympiads. Anup ji, it is not new approach. It is only we are going in depth. हम नंबरों की दुनिया के अंदर जा रहे हैं बस. Just like Ramanujan, how Ramanujan could answer when he was bedridden, and we know that taxi number, taxi cab concept 1729. How Ramanujan could recognize that 1729 is the sum of two different cubes in two different forms? Because he was magician, number magician. And we want each and every child must be number magician first, because numbers के बगैर mathematics नहीं है. We are doing coordinate geometry, we are finding coordinate pair. Coordinate pair normally numbers लिखते हैं. We are not writing कि A, B is a coordinate pair. In general, I am saying. So numbers to बनानी पड़ेगी. Just I am throwing questions from my side, and I will request from all of you. I am looking for answers. Now my first request. Yes, Megas, we are coming for that also. Just wait, just wait. Listen very carefully. Can we transform the equation from now onwards? The definition of a prime can be guide students like this. A number having exactly two distinct divisors must be a prime. I repeat, a number having exactly two distinct divisors must be a prime. जिस संख्या के दो भिन्न भिन्न भाजक ही संभव हैं, वह सदैव अभाज्य संख्या कहलाएगी. It's a perfect, pure definition. And how it can help us? Listen very carefully. Can we find a number having exactly three distinct divisors? Anybody? Please write to comment. Find the smallest number which can have exactly three distinct divisors. Dr. Anurup Kaur is offering answer as 4. I think it is correct. Yes, Mega, including the number itself. Rafiq ji, we are asking that number is having exactly three distinct divisors, including itself also. 4 is correct. Can we answer which number is having property of 2 digit? The smallest 2-digit number having exactly 3 distinct divisors? Rupesh Jha has answered. It should be square of prime. Every square of prime will have a property. It will have exactly 3 distinct divisors. Listen and understand. Just think about it. अगर ये 4th class के बच्चे को सिखाया जाएगा, then which kind of mathematician group we will have in Bharat in near future? Not only in Bharat, across all over the globe. Because we need group of mathematicians who can work on different segments. Polymathematicians we need, who are working in medicines, who are working in electronics and a different field of sciences. हमें उनकी जरूरत है अभी फ्यूचर में. Because of this kind of pandemic, we need that multivariant persons who can focus on mathematics and who can apply mathematics in different field of practical life. Now, as Rupesh ji has suggested, a prime square will have 3 divisors, exactly 3, 1p and p square. Before that, we have already done. A prime can have exactly 2 divisors. Is it okay? Right, Shanky has answered, Noah has answered. The double digit number which is having exactly 3 divisors is 25. Can you answer the smallest 3 digit number having exactly 3 divisors? 121, right? We got the idea now. We need only prime numbers. Now, can we answer which number will have exactly 11 divisors and number is in between 1 and 100? Primary teachers first, because this section starting timing we are taking for primary. We'll come down to middle and senior also fast. Quick, anybody? A natural number in between 1 and 100 which can have exactly 11 divisors. Which number can be there? Noah has answered already, but that is not in the range. 1024. It is 2 to the power 10. This is the only smallest possible number because 2 is the smallest prime. And we know that for 11 divisors, we should have p raised to the power 10. This format can offer 11 divisors. Now the catch is here. Find the smallest possible number which can have exactly 4 divisors. Six, all have answered here. Now, smallest possible 2-digit number. Next question is the same concept. 10. It is already here. No, sir, I think you're not teaching only primary. You can answer. Let others try who are teaching only primary. Because we want upgradation of primary fast in near future. 3-digit number. The smallest possible 3-digit number which can have exactly 4 divisors. Vishal sir is offering 143. Anybody else? (102) is already here, 125 is already here. Now we have got the variance. अब क्वेश्चन अच्छे बनेंगे इसके बाद. Now we are entering from primary to middle section. हम अब क्लास 4 से 6 7 की तरफ आ रहे हैं. Now, in case a number is having exactly 4 divisors and it is of 3 digits, what is the possibility? या तो वो नंबर होगा हमारा किसी प्राइम की पावर 3, तो इसके 4 डिवाइजर आएंगे 1 p p square p cubed. Other than this, can we have any other format which can offer 4 divisors? Because we know that if a number is a prime, it can have 2 divisors, 1 and p. If you take another prime number at q, it can have again 2 divisors, 1 and q. And if I take combination of p into q, then 2 in left column, 2 in right column, I will get 4 divisors. Exactly as we have done in case of 10. Here. This one. It means any number which is having 2 prime numbers as factors, only 2 numbers, that will offer 4 divisors. It means p into q format will offer always 4 divisors, which are 1, p, q, and p cross q. No, the question is defined for us. We have to only find smallest 3-digit number which can have exactly 4 divisors. Now count wise, smallest 3-digit number is 100, but 100 is 2 into 2 into 5 into 5. It will have 9 divisors. 101, it's already prime, 2 divisors. 102 is 17 into 3 into 2, it will have 8 divisors. 103, already prime, 2 divisor. 104, 2 to the power 3 and 3 to the power 2 to the power 2 and 3 to the power 3. 27 4s are 108. Okay. 104 we are discussing first. 104 is what? 104 is 2 to the power 8 and 2 to the power 3 and 13 to the power 1. 2 index 3, 13 index 1, it will have 8 divisors. 3 index 3, 2 index 2, it will have 12 divisors, 108. In between these, we have already left 105, 106, 107. If I will focus specifically on the number 106, I can find the output as 106 can be written as 2 cross 53, and 53 is a prime. Now we have got 2 prime numbers here. It means 106 will have 4 possible divisors, 1, 2, 53 and 2 cross 53. Yes, Keshav is raising hand, please. Thank you, sir. Keshav is where? Keshav has raised hand. Sorry, I'm not able to get Keshav here. अमित सर, मैं रिक्वेस्ट टू प्लीज आप फॉलो करते रहिएगा. इन केस क्वेरी आ रही है तो आप प्लीज शेयर कर दीजिएगा.
Yeah, sure.
Sure, please. Thank you.
Yeah.
Now I am sharing one question from Olympiads. One standard Olympiad which is being organized by.
आवाज जा रही.
Hello.
Sir, continue, please.
Okay, sure. One standard Olympiad which is known as in Bharat, that is RMO, Regional Mathematics Olympiad. उसका भी pre-stage भी start हो गया. When we have pre-RMO, then RMO. After that we have filtering, and then filtered group will send for training as INMO, Indian National Mathematics Olympiad, and they will compete after that stage, IMO, International Mathematical Olympiad, which is being organized by MA. MA is Mathematical Association of America, and they have network of all associations across the globe in different countries of mathematics only. Now, starting point is pre-RMO and RMO. Now, pre-RMO and RMO is a age-bound system. A child studying in class 9th or below can appear in it. Somewhere they have exceptions, including children of class 5 or 6 are appearing, if they think they can crack the question paper. Now, questions के type क्या, which kind of problems they are asking, we have one example here. A number n is less than 30 and it has exactly 4 divisors. Find all the possible values of n. Here n is a natural number. N is in between 1 and 30. It means 0 to 30 बीच में है, 1 to 29 इसका option है. Yes, I am getting some results in chat box. Like this you can find definitely. I'm just asking about the question paper have to solve a class 5 student because that is the youngest child who can and take entry for pre-RMO and RMO and solving. Class 5 को अच्छा जो 10 years का हो रहा है लगभग 10 and a half years का. How the child will develop the mind? We have to work on that. A number having exactly 4 divisors we have already done. It should have either prime की power 3 होगा or it should be in the format of 2 primes product. Cube of a prime or third power of a prime in this range, we have only 2 numbers, 2 index 3 and 3 index 3. That is 8 and 27. Now P into Q. If I take 2 prime numbers, then definitely I have to start with the smallest one and make pair with it of other primes like 2 into 3, 2 into 5, 2 into 7, 2 into 11, 2 into 13, 2 into 17 and so on. But we have to be careful, the number should not cross limit of 30. 2 into 17 is out of range. Then after 3, we have to make combination 3 into 5, 3 into 7, 3 into 11. Again, 11 is out of range. Then with 5, we cannot take any possibility, complete out of range. So we will have total output 1, 2, 3, 4, 5, 6, 7, 8 and 9. 9 numbers in the given range can offer output as 4 divisors. The problem is not difficult, but yes, problem is difficult for a child of class 5. Class 5 is the entry level. The child has taken entry in April or July somewhere. And the examination of pre-RMO is being conducted in the month of August or September somewhere. The child is not having enough exposure. We have to seed the ideas of number theory from class 4 and propagate to number 5 easily. Because this is the correct age, in my experience, best age we can say for number theory ideas development, 4, 5 and 6. Class 4, 5 and 6 as per NCERT syllabus I'm talking about right now. Now, I am coming down to some other concept. Now, this is middle school concept because time is limited. It's already 10. Now, middle school concept we are starting from here. This one basic idea you will all be having from different NCERT book and other reference books. A number ending with 5. Yes, Hina, please type your message.
It is better if you face any difficulty or any doubt, kindly. Okay. It was by mistake, no problem. Sir,
Okay.
please continue.
No problem. A5 squared. This technique is already shared in majority of books that A multiplied by its successor. The right section is 25 and we have many examples in books. We as a teacher know very well how to solve it. In case anybody has doubt, they can refer our Facebook page, IMM Facebook page, we'll upload the ideas also, no problem. But in case the numbers are not ending with 5, still we have ideas from Vedic approach. Vedic approach is systematic in case some person is doing proper research on it. A1 square. A1 square becomes A0 square plus A1th odd number. For example, 31 square is 30 square plus 31st odd number. And we know that nth odd number is defined as 2n minus 1. We are talking about the group of natural numbers only. Therefore, 30 square is 900. 31st odd number is 2 into 31 minus 1. That is 961. Similarly, A2, A3, A4, we have all the patterns. There is no jump. And the proper researchers who are doing PhDs or proper research in Vedic mathematical system, they are sharing all the ideas in sequence. That is the main requirement of future. If a child is coming from class 4 to 12 in 8 years duration, or somewhere in lesser than that also, or more than that might be, then the child must be very much crystal clear concept in mathematics especially. Hona chahiye. It must be there. Otherwise, he or she cannot beat future competition of different segment. Mathematics, I'm not talking about bookish mathematics only. The mind must be mathematized. Now, in case I'm coming to A2, the rule is again not very tough. That is A0 square plus 4 times A1. Like simplest example, I'm taking 12 square is 10 square plus 4 times 11. That means 144. 22 square, that is 20 square plus 4 times 21. That is 484. And so on, we can work out. We have limitation of time, I'm not taking more examples here unnecessarily. But this is the basic idea how that concepts are being developed in ancient mathematics, which was in Vedic Gurukulams for past 8,000 years. It is somewhere in different parts of globe currently also. It is increasing very fast. Am I clear? This concept is fully clear to each one of you. I'm giving break of 1 minute in case anybody has query or doubt. Please write in chat box. Okay, I think majority is having acceptance. No problem. Thank you. Thanks so much. Now, in case we are coming to A3 or A4 or further, then we'll take help of A5. Like A3 whole square, A5 whole square minus 4 times A4. For example, 13 square is 15 square minus 4 times 14. That is 225 minus 56. What is the answer? 169. This is the actual coding you must see from. I'm practicing on this coding right now. How, and I was just thinking how Mr. Bill Gates started coding at the early age of 7 years. 7 years, very young age, we can say. 7 into 3, 2100, 7 to 6, 42. It means roughly 2500 days. A person who came to our earth 2500 days before, that junior kid is started coding. And this is the pattern of mathematics we have to seed in our juniors' mind so that they can think of coding easily. Coding is not very tough as per my experience till now. In future, it may be tough. I don't know. But till now, I am enjoying it. Very fine. Can you guess what should be the pattern of A4 square? I am just giving all of you a chance to think over it. Simi ma'am, we are just here to change the system of future mathematics because it has to be changed somewhere. It is 21st because just like in these 2.5 months, we have seen coronavirus pandemic has already changed each and every pattern of across each and every country's system. They are not opening their schools, colleges, restaurants, bars, malls, everything is closed. So we cannot say the mathematics which is going on that is always perfect. It is okay for future also. We have to change. We all have to raise our voice. हम सब उठाएंगे आवाज तब कुछ change आएगा. We have to send request letters, suggestions, feedbacks to MHRD and different institutions which are designing our syllabus or future course material, curriculum plan. We'll request them kindly consider these techniques. Okay, I'm coming back to this A4 square. Please, anybody has any idea? Please type your idea in chat box. Quick. What should the pattern? The hint is same. Ekadiken Purvain. I have already shown earlier. 31 square was 30 square plus 31st odd number. 31 was is 1 more than 30. Himanshu, I will share all the details. Don't worry. I will share all the details of Vedic concepts. A4 square, we can write down. This is 1 less than A5. It means A5 square minus, yes, A fifth odd number. Correct. It means example लेते हैं किसका 114 square becomes 15 square minus 15th odd number. That means double to 5 minus 29. 196. Unity. Because we know the numbers are ending with 1, 2, 3, 4, then 5. 5 is the central value we are considering here. Then 6, 7, 8, 9, then definitely 0. 9 is just before then 0 ending number. It will follow the same rule as we have for 1 ending number. The property of 1 and 9 is similar. Everywhere, like 1 square ends with 1, 9 square ends with 1. 1 cube, 9 cube will have a sum of 10. 1 to the power 4, 9 to the power 4, again ends with same. Even powers end with same, odd powers will have sum of 10. Similarly, for 2 and 8, we'll have similar property. We can see the pattern. Complete mathematics, Vedic mathematics systems are based on observation, Vilokana. In case we have a good observation, we can develop ideas very well from the root level to top level. There is no jump, no gap at all. Am I clear? Please respond in chat box.
If a few yes or no are coming, then only the presenter can know. Okay, sir.
Okay,
So
thank you.
Very much clear. Please proceed.
Fine. Thank you. Now, can you derive the formula for A6 at your own? One formula will back up here and then we move on to next concept. This I want to test from your side, please. Again, hint is same. A4 is 1 less than A5. A6 is 1 more than A5. The formulas must be similar. It is mathematics only. Develop the formula. Think over it. And my request, please guide students of class 4 and 5 these ideas. We need training from that level only. Meghaji is asking why you should tell children to use this concept rather than using direct multiplication. Generally, students say this. Okay, no problem, ma'am. In case the number is having 3 digits, that's 744 square. Or in case I want to do leg pulling, 4-digit number, the children will face difficulty. We want a proper system in their mind, has to be seeded. The pattern they have to follow. They should not memorize again and again how to multiply 4 digit by 4 digit, 5 digit by 5 digit. They should not do it because computer programming chalti hai 2 digit pe, 0 and 1 pe. And the complete coding is working on binary. Binary bit-byte system, we have already done somewhere in schools and colleges. So we have to do basic, fundamental. Vedic system is going on fundamental. If number is ending with 4, same pattern, no violation. Similarly, A6 square becomes A5 square plus A sixth odd number. Like 16 square is 15 square plus 16th odd number. That means 225 plus 31, or that becomes 256. Right, Firoza has given the answer, Richa has given the answer, Rafiq already given. Most of you have idea now. Just try to inculcate the idea in junior's mind. class 4, 5, 6 maximum. Now they can develop a pattern for themselves. This is the process of sequencing. No jump is there. In proper Vedic mathematics, there is no jump. I request to most of you, in case you are interested for research purpose, you can join. I would be more than delighted to invite you on our platform. Now the time limit is allowing only 17 minutes are left. It means not more than 22 minutes we have. I am just coming down to one more concept. One more concept we can share from NCRT mathematics class 9-10 somewhere. The topic is arithmetic progression. And in arithmetic progression, one problem they have given, if numbers are 1, 2, 3, 4, 5 and so on given in sequence up to n, a number in between there is written as k, such that the sum of left hand side numbers is equal to sum of right hand side numbers. And one hint is also there given, 1 plus 2 plus 3 plus 4 plus 5 is equal to 7 plus 8. It means it is indicating k is 6 and n is 8. This is one example they've already printed in the NCRT book. Can we find 3 more pairs? K comma n. Can we find 3 more pairs like this? Just, I'm offering you 2 minutes to think over it. 120 seconds you have. Please think over it. No, sir, you will not answer. You are not teaching primary classes. I think so. Lois is answering very fast, very quickly. Because the concepts I want from class 8th, this is NCRT 9th or 10th class question, but the problem is for class 7. They can solve it. 7th class students solve it. Or maximum 8th, because in 8th, officially we have squaring, a topic of squaring in NCRT book. Okay, I am just sharing the idea. Anybody wants to take initiative? Please in chat box. Next pair after 35 and 49. K is 35, N is 49. Next pair, can you answer? No, sir. You please stop. Okay, I'm just continuing. Please observe. This concept we are teaching somewhere in primary or middle classes, I think, not primary. 1 plus 2 plus 3 up to and so on. Some natural number r, the sum becomes r into r plus 1 ka half. Am I right? Participants, please share yes or no. Okay, somewhere in 9th we are teaching. We should start this concept in class 7. 9th is too late. What? Because Bill Gates started coding in 7th class, and 7th class child in India is in, I think, 4th class only. Now 1 to r, the sum of natural numbers becomes r into r plus 1 ka half. If you go to the question, it becomes 1 plus 2 plus 3 up to k minus 1. Then k is the indicator or the barrier. We have to jump off that, and then k plus 1 up to and so on n. Right hand sum and left hand sum, if you solve, sigma of k minus 1, we are denoting by symbol sigma, sigma n minus sigma of k. It becomes k minus 1 into k ka half, which would be equal to n into n plus 1 ka half minus k into k plus 1 ka half. all 2 will get cancelled after taking proper shifting and everything. K common, 2k square, this. Okay. We will get k square is equal to n plus 1 ka half. Now this format is called as Brahmagupta equation. A few years back it was only equation, but a lot of mathematicians have already accepted that this fact was discovered by a Bharatiya mathematician, Brahmagupta, and now it is officially Brahmagupta equation in 2 variables in quadratic format, single equation. How to solve it? There are typical methods in many books are given, but in Vedic math we use concepts of prime number. How we can use it? Now, if n and n plus 1 after multiplying and dividing by 2, the result is a perfect square. Can we start like this? N and n plus 1 are 2 consecutive natural numbers. What should be their HCF, highest common factor? 1, correct? All agree? Because HCF must be a difference of 2 numbers. HCF must be a multiple of difference of 2 numbers. Different 2 numbers consecutive, the difference is 1. It means HCF of n and n plus 1 is 1. Now we are also sure, Tripti, just wait, after session you'll get everything. All of you will get all recording, each and everything, don't worry. HCF of n and n plus 1 is 1. Now if these two are consecutive, we are also very much sure that one must be even and other must be odd. The even number can be divided by 2. Odd number, if we divide by 2, decimal aayega usme, that is not perfect division without any remainder, not possible. Now if I consider n is a natural number which is even also, if I divide by 2, what should be the output? I repeat, n is an even natural number. If I divide by 2, what would be the result? Different answer aa gaya. Okay. Yes, both are possible. No, we can't say odd even. It should be integer only. Because even numbers are having different properties, like 2 and 6, both are even. But half of both are different. 2 and 4 are even again. Half of are different. Let's say 2 and 4 we take. 2 ka half ho gaya 1, it is odd. 4 ka half ho gaya 2, it is even. Agree? So for every even number, if we take divide by 2, we cannot say it is even or odd. It should be. It can be anyone. We cannot say only even or only odd. Not possible. It should be natural number, correct? Yeah. Even number का half करने पर answer आएगा. A new natural number will get here. Now, in case we consider here that n is even, then n plus 1 must be odd. And even को divide करने half से तो answer आ गया natural number. Let's say it is m. Now, can you tell me what should be the HCF, highest common factor of m and n plus 1? Even I have taken half of it, and the attached, just successor odd number I have taken as it is. What should be the highest common factor of these two? Who can tell, please? One only. Because we are dividing by 2, we are not multiplying. The highest common factor only get changed if we are multiplying any factor by some other bigger multiplier. हमने 2 divide किया, downside आ रहे हैं. Downside आने पे factor change नहीं होता SCF का कभी. It has SCF has to be 1 only. Now, it means we have got that m, which is n by 2, and n plus 1. For this section, the SCF is always 1. Now, in case n plus 1 is odd number, And we have already taken that k square was equal to n into n plus 1 ka half. It means n plus 1 must be a perfect square in itself. This is the main basic idea here. Because n by 2 already divided हो चुका है, and even हम मान चुके हैं हम n को divide के 2 से, we have divided by 2. The output is an integer. N plus 1 is an odd, and the product of n by 2 and n plus 1 is a perfect square. It means n plus 1 has no link to division by 2, no connection. It should follow the perfect rule of squaring or power making. If the result is a perfect square, n plus 1 is perfect square. If result is perfect cubed, n plus 1 must be perfect cubed. If result is perfect fourth power, fourth index value, then the n plus 1 factor must be exact fourth index value. Same property follow karega. Now, odd numbers, the question is framing right now like this. We have to focus odd perfect squares whose immediate neighborhood, either left or right, which are even number but obvious, half of anyone is again a perfect square. I'm repeating a sentence, listen very carefully. If k square is here, n by 2 is here, n plus 1 is here. If n plus 1 is a perfect square, now from theory of division of perfect squares, we get the output is also a perfect square. This step is clear to all of us. Please confirm quickly in chat box. Fine, good. Now, we have to just work out how many odd perfect squares we can find out very fast. I know that 1 square is 1, 3 square is 9, 5 square is 25, 7 square is 49, and so on. We can find the answer easily. I'm just working out fast. 9, I am taking neighborhood of 9. Pre-neighbor, before neighbor, the predecessor is 8. Half of 8 is 4. And we know that 4 into 9 is 6 square. Then I take next number as 49. 49 is 7 square. The next number, successor, is 50. And half of 50 is 25. It means it becomes 35 square, and so on. We can generate more results. Right, Vishal sir already got the answer. We can find more and more pairs. 288, if we take n is 288, next number is 289, 288 ka half ho gaya, 144. 144 into 289 is 12 into 17, that is 204. We can work out all these numbers are in our range, proper range. Is it clear to all of us? Are we agree we can teach these concepts in class 7th and 8th? We have to be, because we want more Bill Gates in future. Okay, the last concept for today's session ending, I am just finishing. It's already 10:26. I have 7-8 minutes, 10 minutes left maximum. I want to take idea of sequence series, arithmetic progression I want to share. Because this is the simplest progression we have already done somewhere in class 9th, or we are continuing in advanced classes also. Arithmetic progression. What do you know about it? We know about it like this. The way I studied in my classes when my teacher taught me A plus D, A plus 2D, and so on. It is a pattern in which a general term TR is defined as A plus R minus 1 into D. This is called as arithmetic progression. This was the definition what I have heard, memorized, and I have seen in many books. But recently, I have submitted one research paper in one conference, international conference, and that was based on arithmetic progression only, AP. I just tried to transform this by using Ekadike Purvain. It is A times R minus 1 C naught. And I can write r minus 1 as r minus 1 C1 times D. This format is okay for all of us. Please agree or disagree in chat box. We can do it. Okay, thank you. Now, what is the beauty of this formula, this approach? In case I have to find SR, sum of R terms, Ekadikein Purvain, one more than the previous one, the rule in Vedic mathematics we are using for last so many years. It indicates the result is A times RC1 plus D times RC2. Both in head script and foot script, we have to increase the values by 1 each. No changes there. Okay, I'm taking examples. I think that will be having more clarity in our mind. Because we all are humans, we want proof with example. 2, 5, 8, 11, and so on. Saksham, yes, please. Type your query here in chat box, please. TR would be equal to A is 2, R minus 1 C0 plus D is 3, R minus 1 C1. What is the sum of R terms? In senior classes, they know how to solve it, RC1 and RC2. I'm not explaining here because we have limitation of time today. And this you can summarize, you can find the answer. The approach is clear to all of us. Okay, thank you. Now I'm sharing one problem from Oxford University entrance examination. Oxford University has asked this question, and this question was very old question from different international mathematics Olympiad also. And in transformed version, it was asked somewhere in IIT, way back in 80s or 90s, you can see on Google. The problem is not very tough. Observe it carefully. 2, 4, 8, 14, 22, 32, and so on. This is one sequence or one format is given. Can you find T100 and S100? Amit sir is requesting to each one of you, please fill the form, feedback form, because feedback is more important for us to plan more and more sessions for all of you. And we have to compile that feedback. We'll discuss, our core team will sit on it and we'll discuss how to plan effective sessions in near future. 2 minutes it will take on.
It will be shared after 5 minutes. Please continue, sir.
Sure. Okay, thank you. Now, yes, Nitish Gupta ji has already answered. This is in difference in AP. But how we can use Vedic maths? Observe. Focus it very carefully. 2, 8, 2, 4, 8, 14, 22, 32, and so on. If I take differences, it becomes 4 minus 2 is 2, 8 minus 4 is 4, 14 minus 8 is 6, 22 minus 14 is 8, 32 minus 22 is 10, and so on. Redifferences. एक बार फिर से difference लेंगे इसका हम pairwise. 4 minus 2 is 2, 6 minus 4 is 2, 8 minus 6 is 2, 10 minus 8 is 2, and so on. Now this step is a common difference pattern, CDP. It is coming after 2 steps down. In Vedic mathematics, call is second order reducible AP. How to find TR? TR, I am just using different color to avoid any confusion. TR, wait, sorry. And SR. I am just generalizing it and I will put the value of 100 each. TR. First रो का फर्स्ट टर्म है 2, सेकेंड रो का फर्स्ट टर्म है 2, थर्ड रो फर्स्ट टर्म इज ऑल्सो 2 हियर. How you will write TR? First term of first row, first term of second row, and first term of third row, all 2's. Multiply first one with R minus 1 C0, second one with R minus 1 C1, and third one with R minus 1 C2. SR we can find 2 times RC1, again 2 times RC2, again 2 times. In this particular problem sabhi 2 are there, all 2 we have RC3. This is the answer, that's all. Now combinatoric solving, we know how to solve it. Yes, we know it is difference in AP, but we are solving a single step. Because as per Vedic mathematics, we have to be computerized now. The time is 10 seconds, 5 seconds, if possible 1 second also. The answer must be perfect, no error should be there. I am writing here in clear cut situation, ki doubt ho raha kisi ko bhi, please observe it carefully. TR is having first element of first row, first element of second row, and first element of third row. Multipliers are R minus 1 C0, R minus 1 C1, and R minus 1 C2. SR is given as similar terms 2, 2, and 2. Now, Ekadikan Purvan means increase the foot script and head script both by 1 each. I hope now it is clear. Rafiq sir, we are on same platform. We are not up and down. No, please. The concepts what I have recovered, definitely my gurus have taught me. And my gurus were connected to somewhere with Swami Bharati Krishna Tirji Maharaj, who rediscovered Vedic mathematics from ancient scriptures. Vedic mathematics was not compiled in bookish form for very long duration. It was in Gurukulams only, in schools only. Ancient schools, we can say. It was compiled in bookish form somewhere in 1920, 1930 somewhere. But as per Swamiji's version, 16 books he had written, all were lost somewhere. And finally, at an age of somewhere around, he was born in 1884. In 1956, he orated, and his disciple, Dr. Manjulata Trivedi ji, had written or compiled the book. The book is named as Vedic Mathematics by Swami Bharati Krishna Tirthi Ji Maharaj. That is the only book available right now. But the 16 volumes which are lost somewhere, those are having great ideas. These ideas I am surfing from there. Some people are guiding me, and definitely pure spirits are with us. We are not at all alone 730 crore persons on this earth. Each and every particle is having spirit, vibration. We have to enjoy it fully, and then we can have a great mathematical future. Pranam. Thanks for coming. Thanks so much. Amit sir, please take over. Ideas I have shared here. This is the flow of Vedic mathematics from primary to senior classes. There is complete continuity. We all have to be united, and I want to invite on JKMS platform those who want to do research work. Please do get connected. We are all here. And thanks to Amit sir, trillions of thanks to Amit sir and Rohit sir, who have taken this great initiative of technical linking. I don't know this much. I am just learning techniques for last 1.5 to 2 months only, when the Corona came. Corona is my teacher. Corona started teaching me how to use technology now.
We all are learning. Yes, Rohit, please.
Rohit, please take over.
थैंक यू सो मच। वो नहीं है कि जो बुक्स में पढ़ लेना या बुक्स के क्वेश्चन सॉल्व कर लेना, मैसेज मच मोर बियॉन्ड दैट। कहते हैं ना, बीइंग लॉस्ट इन मैथमेटिक्स इज वन ऑफ द ग्रेटेस्ट एक्सपीरियंस वी कैन एवर हैव। सो You all are invited to get that experience, to be the part of IMM, Ignited Minds of Maths group. It is actually a group of मैथ्स एंथुजियास्ट और पिछले 4 सालों से हम अलग अलग प्लेटफॉर्म्स पर अलग अलग जगह मैथ्स के प्रचार के लिए, मैथ्स को सिंप्लीफाई करने के लिए, मैथ्स को और इंजॉयबल बनाने के लिए काम कर रहे हैं। तो आप सभी का वेलकम है और आप सभी हमसे जुड़ सकते हैं। प्लीज़ हमारे फेसबुक पेज को लाइक कीजिए और उसको फॉलो कीजिए, और आगे भी हम आपको अच्छे अच्छे सेशंस ऐसे ही देते रहेंगे। प्लीज़ बी विद अस और ग्रेटिट्यूड फॉर ज्वाइनिंग विद अस टुडे। अमित सर, योर फाइनल वर्ड ऑफ
Okay, right now I'm going through the chat and there are few those who are even saying they are not able to get the link or link is not copied. So in case if you are not able to copy the link from here, what exactly you can do, just check out in the chat. I have shared one small link of bit.ly, https:/:: आ जाएगा, वो आपको पता ही है इस तरह से, then bit.ly/IMM feedback. Just type it in your browser. The link will be automatically open. It contains only 4-5 questions to be answered, and link has to be typed. Yes, as Vishal sir is saying, I don't know how come it is possible. It was possible. I was able to just click on that link and it was clickable. But if there is a problem, please find out the solution for that. Copy this, type this in the browser. You will get your participation certificate in your Gmail account as such. So once again, thank you, Maruti sir, for this wonderful session.
Thank
Though
you.
frankly, I must admit that I could not attend and understand each and everything because I was busy reading the chat and I was receiving many phone calls because already there were 100 members in our Zoom meet and about 100 were actually watching us Facebook Live. So we need to plan out and have to go beyond and having a license of say 500 participants in coming future. Thanks all the participants for joining us, and I am sure that we will be hoping and expecting the similar sessions by Maruti sir and all other enthusiastic mathematics teachers and learners in future also. In case any one of you is willing to give a lecture over here or take the such sessions, please do contact us. Write down in your feedback form. We will get in touch with you. Thank you very much.